All right, everybody, today in this lesson, last one for this unit, we're going to be solving radical equations. And you might notice there's a strange looking word, and that is the word extraneous here. So when we are solving equations, we need to check for extraneous solutions. And that is basically a number that works when we were to solve out these equations after raising both sides to a specific power. However, if we plugged it back in, we might get a negative underneath a radical or something like that. So kind of looking ahead, if I were to get an x value, say I think x is 7 for this first equation, 1 minus 7 would give me a negative 6, and I don't like seeing negative 6 under a square root. I could have a negative under an odd number root, so this is a third root, that's okay, but never an even. So in order to solve this, we need to have kind of prior knowledge of how square roots work. If I ever wanted to get rid of and nullify a square root, I could square something. Squaring and square rooting are inverse operations, so they would essentially nullify one another. Similarly, if I have a third root and I wanted to get rid of a third root, I would raise that to the third power. A third root and a third power would nullify each other. If I had, and I'm just making this up, a 17th root, and I wanted to nullify a 17th root, I'd raise it to the 17th power. We're never going to see that in this class, by the way. All right, so when we solve, first thing you want to do is isolate your radical. Well, fortunately on this side, the radical is all by itself, and there's also a radical on the other side. Once your radical is by itself, you're going to raise it to a certain power to cancel it. Right now I have a square root. There's no index here, so I assume it's a 2. So what I'm going to do is raise both sides, because remember, whatever I do to one side of the equation, I have to do to the entire other side of the equation. Raise both sides to the second power. What's going to happen is that second power is going to nullify the radical. So over here I'm left with 1 minus x equals 2x plus 4. Well, now this is just a straight up equation to solve. I could add 1x to the other side, subtract away 4. So now I'd have 1 minus 4 is negative 3, x's cancel, equals 2x plus x is 3x, 4's cancel, therefore x is negative 1. But I have to make sure that I'm not going to get a negative value when I plug it back into the original. So if I plugged in negative 1, 1 minus negative 1 is really 1 plus 1, so 2. So square root of 2, is that the same thing as 2 times negative 1, negative 2, plus 4? Yeah, that checks out. Awesome. All right, next one. We have a little bit of work to do right out the gate. I know that I'm going to have to raise both sides to the third, because that's how I get rid of a third root. But I need to have this radical portion isolated first, which means this 4 has got to go. Well, quick fix. This 4 is being multiplied, so to undo that, I'll divide it over. So now I've got the third root of 2x minus 1 equals, that'd be 3. My radical is now isolated. As soon as my radical is isolated, I'm going to raise both sides to the power of, well, to undo a third root, I'm going to raise to the power of 3. On the left-hand side, the radical just nullifies due to the power, so they kind of knock each other out. On the right side of the equal sign, I have 3 to the third power. This is not 9. It is not 3 times 3. It is 3 times itself 3 times. So 3 times 3 times 3, which is 27. When I go to solve this, I'll add 1 to the other side. That's 28 divided by 2. I get x equals 14. And let's plug it in to make sure. 2 times 14 is 28, minus 1 is 27. The third root of 27 is 3, times 4 is 12. Yeah, we're good. All right, second one. Nope, third one. Here we go. I'm already kind of anticipating having to raise things to the fourth power, but I need this radical by itself. Quick fix, let's subtract 1 to the other side. So fourth root of 3x plus 7 equals, that'd be 2. So now we're going to raise both sides to the fourth power, because that's how I get rid of a fourth root. I get 3x plus 7 equals 2 to the fourth power. That is not 8. It is 2 times 2 times 2 times 2, which is 16. Then to go solve this, we do 3x equals, if I subtract 7 over, 3x equals 9. Therefore, x equals 3. Plug that back in. 3 times 3 is 9, plus 7 is 16. Fourth root of 16 is 2, plus 1. Yep, that's 3. We're good. Excellent. All right, on to the slightly more challenging ones. Here I've got the square root of negative 2x plus 34 equals x minus 5. Well, the radical is already isolated, which means I can raise this to the second power, but I have to do the same thing over on the other side of the equal sign as well. This is going to result in having an x squared, which means it'll take a little bit longer to solve. Now, when I have x minus 5 quantity squared, that's really x minus 5 times another x minus 5. Big mistake is people will think it's x squared minus 25, and that is not the case. So on the left side of the equation, radical and the power knock each other out. So I have negative 2x plus 3, 4, 34, equals, if I did some distribution here, this would be x squared. I'd have a negative 5x and another negative 5x minus 10x plus 25. All right, so now I'm trapped with this x squared. Bummer. Anytime you're trapped with an x squared, typically you want to see an equals 0 in the mix. Because once we have equals 0, we can factor, we can solve, and go on with our day. So I'm going to throw the 2x over to the other side. If I add 2x, that'll give me a negative 8x. Why did I put a squared? What am I doing? So I added 2x to the other side. And then I'd have to subtract 34. That would give me a negative 9. So now we factor and we solve. All right, so here I need two numbers that would multiply to be a negative 9, but add up to be a negative 8. That'd be a negative 9 and a positive 1. Therefore, x equals 9, x equals negative 1. So I'm going to box these for now, but one of them might be extraneous. Who knows? Let's plug in and find out. Again, we don't like to see negatives underneath square roots. If I plugged in 9, negative 2 times 9 is negative 18, plus 34 is going to be 16, and then 9 minus 5, we're good. So 9 works. 9's good. Let's try negative 1. Negative 2 times negative 1 is a positive 2, plus 34 is 36. Okay, so the square root of 36 is 6, equals negative 1 minus 5. Negative 1 minus 5, so that's actually not going to work, right? Because negative 1 minus 5 would give me a negative 6. So negative 1 here would be considered extraneous. All right, last one. First thing I need to do is get my radical all by itself. So this x has got to go. I'm going to throw it to the other side. So this is now going to look like x minus 2 equals the square root of 2x minus 1. Well, this is looking pretty dang familiar to the one we just did. So we square both sides. On this side, the radical and the square just kind of knock each other out. So I have 2x minus 1. Over here, I have x minus 2 quantity squared. That's x minus 2 times another x minus 2. So distribute that out, x squared minus 4x plus 4. Just like the previous example, if we ever have an x squared that we're stuck with, chances are we'd like to see an equals 0 on the other side. So the 2x has got to go. The 1 has got to go. We get x squared minus 6x plus 5 equals 0. So now let's factor and solve. Just as a heads up, this combination of 6s and 5s always trips people up. You have to make sure you're keeping track of what's positive, what's negative, because you can have a combination of 5 and 1 or a 2 and a 3, and both of those combinations in some way, shape, or form can work if you're multiplying to 6 or adding to 6 or multiplying to 5 or adding to 5. So make sure you're being very, very careful because it's very, very easy to confuse these different combinations. Okay? So right now I know I have to multiply to be 5. So if I kind of take my time through this, I know it's got to be a 5 and a 1 if I'm multiplying to 5. Now it's a positive 5, so they're either both positive, 5 and 1, plus 5 plus 1, or both negative. The fact that they add up to a negative 6 means they both have to be negative. Therefore, x equals 5 and x equals 1. Let's check. I'm going to plug in 5 for x. 2 times 5 is 10, minus 1 is 9. Square root of 9 is 3. Negative 5 plus 3, yes, that's negative 2. So 5 works. Excuse me. Next, let's try 1. 2 times 1 is 2. Minus 1 is 1. Square root of 1 is 1. Is negative 1 plus 1 negative 2? No. No, it is not. So when we plug that value in, it no longer works. X equals 5 is our solution. All right. As is the drill, if you have any questions, please do not hesitate to let me know. Good luck, have fun, be safe.